Yes, students, good morning. I'm audible. Yes, students, good morning. I'm audible, dear students.
Yes, sir, audible.
Okay, very good morning to all of you. So welcome to Analysis and Design of Algorithm class. Okay. So yesterday we have made some discussion. We have solved a problem. We have solved a problem on this depth first search, isn't it? So based on this problem, so today we are going to give the algorithm and as well as some of the analysis part. Then after that we are going to make some discussions on topological sorting or topological ordering. So now I am going to write this algorithm to traverse the graph using DFS. So that is algorithm here. So algorithm DFS. So there are so many parameters. A, N, S, U, there are some of the parameters. So the purpose of this depth first algorithm is traverse the graph from the given node source in DFS. So inputs and the inputs A is nothing but adjacency matrix adjacency matrix of given graph. Okay. Given graph. Then n means number of nodes in the graph. Then we have u. U is nothing but the way the traverser is in shape. What we can say, so in the graph, the bar. Similarly, we have S. S indicates the vertices that are visited. Okay, visited vertices. Then A N U S A N U S. These are the parameters. Then T is the output term. Coming back to the output, T is nothing but frequency. Create U comma. So these are the arguments. Then the algorithm x of u equals 1 indicates visited. Perfect.
Sir, algorithm first line ಕಾಣಿಸ್ತಿಲ್ಲ sir. Full ಮೇಲ್ ಹೋಗಿದೆ.
ಈಗ
Sir, ಇವಾಗ fine.
Okay. Next, for every p adjacent to vertex P, vertex U, if V is not duplicated, V is not duplicated, then here A, comma, 0, equals to here A, comma, 1 equals to B. Then the recursive part, again, DFS of U, N, V, S, A, N, S, B, B. So this is the algorithm for the first search traversing. Work பண்றா?
Yes, sir.
Okay. So now the analysis part, can I have this?
Okay, sir.
The analysis part is same as DFS. Analysis is same at least as your first. That is not talking. So it is as same as the bread percentage. Okay, that is the first one. Canada.
Yes, sir.
Now I will give one problem for all of you. You do this problem at home as a homework. So you take the problem. I am going to dictate the problem now. Ella,
Ha, sir.
ಬರ್ಕೊಡಿಯಲ್ಲ ಸೊ ಇದನ್ನ ಮನೆಯಲ್ಲಿ ಹೋಮ್ವರ್ಕ್ ಓಕೆ ಯು ಡೂ ಇಟ್ ಅಟ್ ಹೋಮ್ ಯು ಟೇಕ್ ದ ಪ್ರಾಬ್ಲಮ್ ಐ ಆಮ್ ಗೋಯಿಂಗ್ ಟು ಡಿಕ್ಟೇಟ್ ಇಟ್ ನೌ ಟ್ರಾವರ್ಸ್ ದ ಫಾಲೋಯಿಂಗ್ ಗ್ರಾಫ್ traverse the following graph using DFS and construct the corresponding depth first search tree and construct the corresponding depth first search tree. Will stop. Give the order in which the vertices were reached. for the first time, bracket hyperbole pushed onto the traversal stack. Pushed onto the traversal stack. Close the bracket. And the order in which the vertices become dead end. The vertices become dead end. Bracket hyperbole popped off the stack. In bracket, popped off the stack. Full stop. Full stop. Also mention the tree edges. And back edges of the graph. Tree edges and back edges of the graph. The graph I am going to write now. Question barcode.
Yes, sir.
Okay, graph per column. So this is the graph. Copy this graph. Understand, yeah? Graph. Anita Barkontra.
Yes, sir.
Okay. So you problem there. You have to apply DFS travels. Okay. You apply the DFS travels. So ಇದನ್ನ ನಾನು ಲಾಸ್ಟ್ ಕ್ಲಾಸ್ ಒಂದು ಪ್ರಾಬ್ಲಮ್ ಮಾಡಿಸಿದ್ದೀನಿ ನಿಮಗೆ. So same time table ಹಾಕ್ಬಿಟ್ಟು so you have to write initial step, step 1, step 2 ಆ ಥರ ಮಾಡಿಬಿಟ್ಟು you have to push the vertices into the stack. If no steps are performed, particularly step 3, no new nodes have been visited, pop the vertex from the stack. So then I problem ಮಾಡ್ಸಿದ್ದೀನಿ ನಾನು ನಿಮಗೆ. Yes? ಬರ್ಕೊಂಡ್ರಾ?
Yes, sir.
Shall I rub this?
Okay, sir.
So you do this at home and you have to show me the output tomorrow. All of you, I will check. So next, applications of DFS. So some of the applications of DFS. So first one, to check whether the given graph is connected or not. To check given graph connected. Second one, to check whether the graph is acyclic or not. Third one is to find spanning tree. Spanning tree ನಿಮಗೆ next video ಮಾಡ್ತೀನಿ. Fourth one, solving puzzles with only one solution. So it means this fifth one, topological sorting. So these are some of the applications of DFS. First one, to check whether the graph is connected or not. Okay. Sometimes you may be having a graph like this. And there may be a vertex, okay, which may not be connected. So this type of graphs, what you can call so the 4 is not connected. So like it is not connected graph. Okay. To check the connectivity, we are going to use the topological, the DFS, to check whether the graph is acyclic or not. Cyclic and that 1, 2, 3. So this is a cycle. Acyclic means there may be a vertex. So this is not a cyclic. So this is acyclic, okay? Because there is no going back, there is no loop. So to check whether the given graph is acyclic, okay? For this purpose also, we are going to use the BFS to find spanning tree. Spanning tree, I'm going to engage in reading method. Okay. So next stage is spanning tree. Solving puzzles in a solve material. Okay, topological sorting, we are next. So topological sorting ಅಂತ ಏನಲ್ಲ, the nodes visited process ಏನಿದೆಯಲ್ಲ ಅದನ್ನ ರಿವರ್ಸ್ ಆರ್ಡರ್ ಅಲ್ಲಿ ನಾವು ಪ್ರಿಂಟ್ ಮಾಡಿದ್ರೆ that is a topological. Tell you shall I rub? ಬರ್ಕೊಂಡ್ರಾ?
Yes, sir.
So next, some of the differences between BFS and DFS. So what you can see, so so data structure. So what is the first difference? What is the data structure in
Stack.
DFS? It is
Stack.
what is data structure in DFS?
Queue.
Queue. So that is the first data structure. I mean difference. So next, two vertex ordering is used as the order in which items are inserted. So in here, two types of ordering. ನಿಮಗೆ ಗೊತ್ತಿದೆಯಾ F41 ಅಂತ ಬರೀತಾ ಇದ್ದೆ. ಏನಿದು F41 ಅಂದ್ರೆ? 4 ಅಂದ್ರೆ ಏನು? Fourth element to be inserted and first element to be
Order of deletion.
this is nothing but deletion or copying ಅಂತ ಹೇಳ್ತೀವಿ. Okay, this is nothing but insertion ಅಥವಾ push in the stack. So we have two types of ordering. One insertion ಅಥವಾ push operation ಗೆ, ಇನ್ನೊಂದು pop ಅಥವಾ deletion ಗೆ. ಹೌದಾ? In case of DFS. But in case of BFS, only one type of ordering. Next, the exploration of node is postponed as soon as the new unexplored node is reached, and the examination of the new node begins immediately. So, postpone of exploration. So, in a cadet, suppose if we have a node here, and we have a node here, we will have a node here. So this is not explored until B is explored. B is not explored until C is explored. So this will be explored because this is a dead end. Then we will backtrack, then we are going to explore B. Then we will explore A. So this is how DFS works. So that is postpone of exploration until dead end. Okay, now. So here, a node is fully explored before the exploration at any node begins. So, any level if you consider, level is explored with all nodes. So, that is the difference. Next, fourth one, tree edges and back edges. What type of edges present here? Tree and back edges are presenting DFS. In case of BFS, ಯಾವ ತರ edges ಇರುತ್ತೆ ಜ್ಞಾಪಕ ಮಾಡ್ಕೊಳ್ಳಿ. What kind of edges present in BFS? ಗೊತ್ತಾಯ್ತಾ? 3 edges and 3 end. ಹೇಗೆ ಹೇಳ್ಬೇಕು? ಟೈಮ್ ಆಗತ್ತೆ. ನೋಡ್ಕೊಂಡೆ ಹೇಳಿ. similar P and cross enters. How's
and process.
Okay. Next. Use it to check connectivity of the acyclic graph. Use it to check connectivity of acyclic graph.
Sir, board ಕೆಳಗಡೆ ಮಾಡಿ sir. Focus.
ಈಗ
ಹಾ sir, okay.
Okay, use it to check connectivity of acyclic graph. Use it to check for connectivity and acyclicity of the graph. Use it to check both acyclicity and connectivity in case of BFS. Okay. Next. 6. Time efficiency is the same. So analysis in the difference of parala. So that is number of vertices. V ಅಂತಂದ್ರೆ ಏನು? Number of vertices. Similarly here also analysis. Let's see. So these are some of the similarities and differences between DFS and DFS. ಬರ್ಕೊಂಡ್ರಾ? ಬರ್ಕೊಳ್ಳಿ. ಎಕ್ಸಾಂಪಲ್ ಕೇಳ್ಬೋದು. Distinguish between breadth first search and depth first search. ಅಥವಾ list the differences between both DFS and DFS traverse. ಆವಾಗ ಇದನ್ನ ಬರಿಬೇಕು. ರೈಟ್ ಮಾರ್ಕ್ಸ್ ಬರ್ಬೋದು. If you have copy, tell me. I will hang it up.
Copied sir.
Okay. So next we shall go to topological sorting. That is one of the main application of DFS. Topological sorting or topological ordering ಅಂತಾರೆ ನಾವು ಇದನ್ನ. So shall I dictate the definition for this? Dear students, shall I dictate the definition of topological sorting, dear students? ಬರ್ಕೊತೀರಾ? Yes? Shall I dictate the definition of topological sorting, dear students?
ಎಸ್ ಸರ್ ಡಿಟೆಕ್ಟ್ ಮಾಡಿ.
Okay, ಬರ್ಕೊಳ್ಳಿ. Definition. ಬರ್ಕೊಳ್ಳಿ. The topological sort. The topological sort of a directed acyclic graph. Of a directed acyclic graph. Directed acyclic graph. ಅದನ್ನ ನಾವು DAG ಅಂತ ಕರಿತೀವಿ. DAG ಅಂತ. DAG ಅಂತಂದ್ರೆ directed acyclic graph ಅಂತ. Okay. So the topological sort of a directed acyclic graph, DAG, that is G is equals to B comma E is equals to V comma E is a linear ordering of all the vertices, linear ordering of all the vertices such that for every edge u comma v, for every edge u comma v is the ordered trade. U comma v, for every edge u comma v in graph G, this is G, the vertex u appears before the vertex V in the ordering. Full stop. A topological sort of a graph can be viewed as an ordering of vertices along a horizontal line, so that all directed edges go from left to right. Full stop. For a cyclic graph, no linear ordering is possible. For a cyclic graph, no linear ordering is possible. ಅಂದ್ರೆ ನಾವು ಇವಾಗ ಏನ್ ಮಾಡಬೇಕು ಅಂದ್ರೆ ಒಂದು ಗ್ರಾಫ್ ಕೊಡ್ತಾರೆ ನನಗೆ, ಎನಿ ಗ್ರಾಫ್. ಓಕೆ, ಆ ಗ್ರಾಫಿಗೆ ನಾವು ಟೊಪೊಲಾಜಿಕಲ್ ಆರ್ಡರಿಂಗ್ ಅಂದ್ರೆ ವರ್ಟಿಸಸ್ ನ ಆರ್ಡರ್ ನ ಕಂಡುಹಿಡಿಯಬೇಕು. ಬಟ್ ನಮಗೆ ಕೊಟ್ಟಿರೋ ಗ್ರಾಫ್ ಯಾವ ತರ ಇರುತ್ತೆ ಅಂದ್ರೆ ಈ ತರ ಇರುತ್ತೆ. 1 2 ಓಕೆ 3 okay. So this is a cyclic graph. From the example. So this is a acyclic graph because there is no loop here. This is a directed. Directed acyclic. Directed ಅಂದ್ರೆ ಏನು ಪ್ರತಿಯೊಂದು ಎಡ್ಜಸ್ ಏನಿರುತ್ತೆ ಡೈರೆಕ್ಷನ್ಸ್ ಇರುತ್ತೆ. ಇದು ಡೈರೆಕ್ಷನ್ ಇರುತ್ತೆ. ಸೊ ಇಂತಹ ಡೈರೆಕ್ಟೆಡ್ ಗ್ರಾಫ್ ಅಲ್ಲಿ ಎಲ್ಲಿ ನಮಗೆ ಸೈಕಲ್ ಇರೋದಿಲ್ವೋ ಅದಕ್ಕೆ ನಾವು ಅಸೈಕ್ಲಿಕ್ ಅಂತೀವಿ. ಸೊ ಇಲ್ಲಿ ನಾವೇನ್ ಮಾಡ್ತೀವಿ ಆರ್ಡರಿಂಗ್ ನಡೀಲಿ. ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ 2, 3, 1. So this may be a topological order. How it will be obtained, I will explain later. Okay. So similarly, if you consider another graph like this one, whether this is cyclic or acyclic.
Cyclic.
This is cyclic. So in this case, we cannot take the topological ordering. So topological ordering can be obtained only in acyclic graph. So this is acyclic. Whereas this one is cyclic ಅಂದ್ರೆ ಏನು? There is a loop back. You can go back. Okay. Shall I rub this?
Yes, sir.
Sorry. Next para. If A depends on B, if A depends on B and B depends on A, if A implies B and B implies A, then it is a, what is the meaning? It is a cyclical one. It is cyclic. A graph, then it is a cyclic. Full stop. Full stop. A graph which is cyclic, a graph which is cyclic does not have topological sequence. Does not have a topological sequence. Okay. So this topological ordering can be obtained in two ways. Okay, ಎರಡು ತರ ನಾವು ಕಂಡುಹಿಡಿಯಬಹುದು. Topological sorting. This can be obtained in two ways. The first one is DFS. First one is DFS. Okay. Second one is source removal. First one. So there are two ways of solving the
Yes, sir.
Next, reading topological sort using DFS. Topological sorting using first one, that is DFS. So ಇಲ್ಲಿ ನಾವು ಕೆಲವೊಂದು ಸ್ಟೆಪ್ಸ್ ಫಾಲೋ ಮಾಡಬೇಕಾದ್ರೆ just like what we have followed in DFS traverse. The first step, that is step 1. Step 1. ನಾನು ಡಿಕ್ಟೇಟ್ ಮಾಡ್ತೀನಿ, ಬರ್ಕೊಳ್ತೀರಾ? Step 1.
Yes, sir.
ಬರ್ಕೊಳ್ಳಿ. Step 1. Select any arbitrary vertex. Step 1 ಬರ್ಕೊಳ್ಳಿ. ಮುಂದೆ ಇಲ್ಲಿ select any arbitrary vertex. Arbitrary ಅಂತಂದ್ರೆ ಏನು? Chronologically first ಅಂತ. For example, ABCD ಇದ್ರೆ A ತಗೊಳ್ಳಿ, 1 2 3 4 ಇದ್ರೆ 1 ತಗೊಳ್ಳಿ. Arbitrary ಅಂದ್ರೆ random ಆಗೋದು ಹೇಳ್ತೀವಿ. To select any arbitrary vertex. Step 2. Step 2. When a vertex is visited, when a vertex is visited, for the first time, visited first time, slowly or because. So when a vertex is visited for the first time, it is pushed onto the stack. So push onto stack. So step 3. Step 3
Yes, sir.
Okay. When a vertex becomes a dead end, when a vertex becomes a dead end, when a vertex becomes a dead end, it is removed from the stack. It is removed from the top of that. When a vertex becomes a dead end, it is removed from the stack. Step 4. Repeat step 2 to 3. Repeat step 2 to 3. Repeat step 2 to 3 for all the vertices in the graph. For all the vertices in the graph. For all the vertices in the graph. Step 5. Reverse the order of deleted items. Reverse the order of deleted items. Deleted items to get the topological difference. To get topological difference of its topological order. You have to follow these steps in order to perform the topological sort. Okay. ಬರ್ಕೊಂಡ್ರಾ?
Yes, sir.
ಸರಿ ಅಮ್ಮ. Okay, the next ಇದ್ರ ಮೇಲೆ ಒಂದು ಪ್ರಾಬ್ಲಮ್ ಸಾಲ್ವ್ ಮಾಡಬೇಕು. Once again we have to take a gap and we have to solve it. Okay. ಈಗ ನಾನು ನಿಮಗೆ ಪ್ರಾಬ್ಲಮ್ ಹೇಳಿರ್ತೀನಿ, ಅದನ್ನ ನೆಕ್ಸ್ಟ್ ಕ್ಲಾಸ್ ಅಲ್ಲಿ ಸಾಲ್ವ್ ಮಾಡ್ತೀನಿ. Now you copy the problem. Clear of this?
Okay, sir.
Okay, problem ಬರ್ಕೊಳ್ಳಿ. Apply the DFS based algorithm, to solve the topological sorting problem, for the following graph. So graph ಬರೀತಾ ಇದ್ದೀನಿ. A, B, effects. Then another one. Now, so this is the graph. Copy this graph.
ಡನ್ ಸರ್.
ಓಕೆ, ಸೊ ನೋಡಿ ಇಲ್ಲೆಲ್ಲಾರ ಸೈಕಲ್ ಇದೆಯಾ ನೋಡಿ. ಐ ಮೀನ್ ವೆದರ್ ಎನಿ ಲೂಪ್ ಬ್ಯಾಕ್ ಚೆಕ್ ಮಾಡಿ ಒಂದ್ಸಲ. ಸೈಕಲ್ ಇದ್ರೆ ನಾವು ಇದ್ರ ಮೇಲೆ ಟೊಪೊಲಾಜಿಕಲ್ ಸಾರ್ಟಿಂಗ್ ಮಾಡಕ್ ಬರೋದಿಲ್ಲ. ಸೊ ಹಾಗಾಗಿ ಮ್ಯಾನ್ಯುಯಲಿ ಚೆಕ್ ಮಾಡಿ ವೆದರ್ ಇಟ್ ಕಂಟೈನ್ಸ್ ಸೈಕಲ್ ಮಾಡ್ಬಿಟ್ಟು ಹೇಳಿ ಹಂಗೆ ನೋಡೋಣ. ವೆದರ್ ಇಟ್ ಕಂಟೈನ್ಸ್ ಎನಿ ಸೈಕಲ್ ಲೈಕ್ ಇಲ್ಲ, ಇನ್ನೂ ಇಲ್ಲ. ಚೆಕ್ ಮಾಡಿ ನೋಡಿ.
ನೋ ಸರ್.
So it is acyclic. It is also called as DAG. DAG and you know?
Direct acyclic graph.
Directed acyclic graph. And we can apply the DFS method in order to find out the topological sort. Okay, so that we will do in the next class. Okay, fine.
Okay, sir.
Okay, I request all of you to give your attendance in the chat box. Shall I run this? Okay,
Yes,
great. Let it be here only. So if you have any queries, you can ask, or else we can stop here. Continue in the next class. Shall we stop?
Okay, sir.
Okay, thank you. Thank you so much for joining my class. Please take care of this. So I'm going to close the session. I request if anyone has not given your attendance,